12, we're going to start talking about polynomials. We've already talked about monomials, which is in the first column here. And a monomial consists of one term. So we have our coefficient, and then we have our variables. Okay? And also a monomial could just be a number. A binomial is when we have two terms. We have our coefficient with our variables, and we have also a constant term. Here we have one term that's raised to the third power, or cubed, and then we have another term here that is squared. Okay, two terms makes it a binomial. So then we also have a special kind of polynomial that's called a trinomial. Tri means three. So you can see we have three terms here. We have the term with an exponent, we have the next term that just has the variable, and we have the last term as the constant term. In the second example, same thing. We have the term that has an exponent, it's raised to the third power, or cubed. We have a variable that is single, and we have our constant term. So we have the three types of terms there as well. Three terms means that it's a trinomial. So just some vocabulary words for you. So this time we're going to tell whether the expression is a polynomial or not, and if it is, then we have to say if it is a monomial or a trinomial. So if we look at the first expression, we see 7m to the negative 2 plus 4. This one is not a polynomial because the variable the variable m has an exponent that is not a whole number. So right here, I'll even put it in red so we can see, this makes it not a polynomial. We cannot have a negative exponent. Okay? If we go to the next expression, we have negative b. We have the only term is a negative b. So that one, there it is a term though. The negative is okay. That makes it a polynomial. And because we only have one term, it makes it a monomial. Again, remember that's one term. Trinomial is going to be three terms. All right. And then our next one, we have three terms. That makes it a polynomial. We don't have any negative exponents. And what type of polynomial is it? It is a trinomial because it has three different terms. The 3x squared, the negative xy, and the negative 1. Have a couple more here that we're going to check out. Let's see, for the first one, 6x to the fourth minus 5x to the third. That one is a polynomial, and that term has, this one has two terms, so I don't have that listed here. That would be a binomial. So this one is a polynomial, goes to the binomial. Use a different color here. The next one, we have three terms. However, notice that the one term has a negative 1. So our second expression here is not a polynomial because of that negative exponent again. And then our last expression, we have none of them have the exponent that would be negative, and we have three terms. So this is a polynomial. What type of polynomial is it? It's a trinomial. Excuse me. The next term we're going to learn is going to be about degree. Okay? The degree of a term is a sum of its exponents of its variable. The degree of a polynomial is the greatest degree of its terms. So the degree must be a non-zero constant, is 0, and the constant the 0 has no degree. So if we look at these expressions here, that was a lot of blah, 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 blah. So let's look at this expression. The first expression is 5x cubed plus 8x minus 9. The greatest degree would be right here. The greatest degree would be this term 5x because it is cubed. Okay, so the degree of 5x cubed plus 8x minus 3 is going to be, oopsie, And if I look at the next one, we have the terms p minus pq, p cubed, q squared plus q to the fourth. Now this one we have a couple exponents. So the greatest degree of the terms is 5. And I got that because I added those two terms. 3 plus 2 equals 5. And that is larger than the single term there, which is 4. Okay, so the greatest degree for this one would be 5 because, again, if we're multiplying, we would add those exponents. It's kind of that same routine. We want to add the exponents of the variables. Right there is that rule. Now, the reason we need to know that is because we will need to know that to put terms into standard form. Okay, that's the important part of the degrees there. So to simplify a polynomial, combine like terms. Remember that like terms are terms with identical variable parts, such as 8ab squared and 3ab squared. They have the same variables, so they have the same parts. A polynomial is written in standard form if it is simplified and the terms are arranged. So, this is the part you need to know. The terms are arranged so that the degree of each term decreases or stays the same from left to right. So if we look at this one, first we have to do some simplifying because I see a parentheses in there. So let's go ahead and simplify our terms here. Remember this. So 2 times 4m would give you 8m. 2 times m squared would give you a positive 2m squared. Now we have to look for our like terms. I have an m squared here, and I have an m squared here. Those are my biggest degrees, so I went to those terms first because they're going to come at the beginning if I'm going to write this in standard form. So I can put in a coefficient there if that helps. So a negative m squared plus 2m squared is going to leave me with a positive m squared. Okay, moving on to the next one, I look for the next, if I'm going to the decreasing in the degree, my next one would be the 8m. There are no other terms that just have a single variable m, so that would be my next term. And then my last term, let's go ahead and put it back in green again. My last term is my constant, and I only have one constant term, so I can put that in there. This equation now first was simplified, so I multiplied out the parentheses. Then I put it in the degrees, and the degrees need to go from greatest to least. So this now is in standard form. So now we have to go to evaluating a polynomial. So we have a volleyball that's hit upward from a height of 1.2 meters, and you can use the expression, so we have an expression here, to find the height in meters of the volleyball in x seconds after it is hit. So it says find the height of the volleyball 1 second after it is hit. So if we look at this, we're going to substitute in the things we know. And so we know that we're going to substitute 1 for t. And how do we know 1 for t? Because t is time and we have 1 second. So I'm going to put in 4.9 times 1 squared plus 8.1 times 1 plus 1.2. Okay, now that's a kind of nice one because we have all these ones. 1 squared is 1. So this is going to say a positive times a negative is going to say 4.9. Positive times positive is going to say 8.1. And then we have our 1.2. Now you can use a calculator for this, or you can just put the like terms together. If you remember, we talked about this a long time ago. It's kind of nice to put is my only negative, and then these two are both positive. It's nice to do some rearranging if we need to put the terms together, combine the negatives, and then combine the positives or in the opposite. And so when you do that, we end up with a final answer of 4.4. So the volleyball's height after 1 second, the volleyball's height after 1 second would be 4.4, I'm sorry, when we said, we put a label on that, that would be meters. The height after 1 minute would be 4.4 meters. And that concludes our introduction to polynomials.